Good evening, and welcome to the Albright Scholar for October 2018. My name is John Pankratz. I teach history at Albright, and each month it's my privilege to welcome BCTV viewers and residents of Greater Reading to take a glimpse inside our learning community up here on North 13th Street, to look at the work being done by teachers and students, and to think about its impact on all of us. Well, we are deep into the fall semester, and tonight we are going to talk about chemistry. In some ways, you see my bottle of wine here, or our bottle of wine. We're going to talk about Louis Pasteur after 170 years. And my returning guest is Dr. Christian Hammond, professor of chemistry and biochemistry, and longtime friend and colleague. We have a lot to catch up with.
Yes.
We want to talk about your research. We want to talk about leave where you spent a year teaching at another institution, sort of a sister institution, I guess, and then also talk about the work of the Department of Chemistry and Biochemistry at Albright and the students that it's producing these days.
Yeah.
Great. Well, let's ask about last year, because you were away from us.
Yeah.
You had an opportunity to teach at a really wonderful college, Smith College in Northampton, Massachusetts.
Yeah, so as you work through your career and you meet more people, I have several conference friends, people I see once a year at your annual conference. And one of my conference friends called last April and said, "We've had a surprise retirement. What do you think about a year at Smith?" And I said, "Okay." And the department and the professional council and the provost were able to make it happen. It turned into an opportunity for me to teach at another institution. It turned out to be an opportunity for Jonathan Geruntho, one of our graduates, 2010, I think. We're not old enough for him to have graduated in 2010. And so he began his teaching career as a visiting professor here.
Right, he had gone off to Washington State and gotten his PhD at the University of Washington.
Exactly, and now he's in Pittsburgh. And then I was in Northampton, moved up, was resident for a year. The winters are a little colder, John.
They are. Western Massachusetts, they call it the Pioneer Valley for a good reason.
Yeah, it's almost the Donner Pass Valley.
Almost.
Sorry. And so, you're teaching a full load, you're doing research with students, you're engaged in committee work, but you're hearing about the profession from a very different perspective. As much as we like to view outside of our own boxes, right? Sometimes you get caught up in the day-to-day, and this was an opportunity to see the world from a very different position.
That's right, without the same level of commitments and investment in the location and that sort of thing.
Exactly. Well, it's nice to be a tourist for a whole year.
To be a guest,
it's
exactly.
a beautiful part of the country. That's one of the joys of being able to do that. I understand you've been doing some traveling around our country recently.
As well, some road trips as well.
It's beautiful out there.
Yeah, it's fascinating to see, and to see a different department and how they organize the curriculum and how they work with students.
Right.
Is it a comparable department in terms of the size, the number of colleagues? Or?
A little larger.
A little bit larger.
A little larger. They have more permanent staff supporting their research efforts, so people to fix the instruments and
set up the labs
set up the chemicals. But that's not atypical for also an elite institution to have that kind of support. I mean, their research demands and publication requirements are greater than ours.
Right.
So they have more support staff to support that. But they're doing the undergraduate research, that intensive education thing as well. And have non-majors courses as well, so they're reaching out into the broader liberal arts community. Carol Christ, their former president, was a huge advocate for that cross-pollination between the humanities and the sciences. I mean, she was spoke on a national stage about that.
Yeah, fabulous.
So,
and of course that's your bailiwick as well.
That's right. Yeah, nothing like a little non-majors lab science, wine and cheese, perhaps. Yeah.
For example. Well, let's talk a little bit about why we have these wonderful models here.
Yeah,
and
this
wonderful bottle of wine. We're going to talk about chirality, or left-handedness and right-handedness in molecules.
Yeah, so a lot of the chemistry we now know in the modern world comes out of the Arab world in, I think it was around 800 or 900 CE, that people started to notice crystals forming out of wine. Now, I'm guessing people had noticed before,
Right.
but now scientists or proto-scientists were starting to write this down and trying to log it and look for patterns
Observe
and
it
trends. Formalize the observations. As I like to say, Isaac Newton saw waves on the beach like the rest of us saw waves on the beach. He just wrote mathematical equations to describe them.
Yeah.
Somehow we didn't do that. So you take a bottle of wine and you pop the cork and you find that either on the base of the cork or in the bottom of the bottle are they're actually quite beautiful crystals. They're wine grape purple and they're really gorgeous. They're very shiny. And what Louis Pasteur noticed about 170 years ago, so we're coming up on this anniversary, or I think we just passed it, he noticed that the crystals were left-handed and right-handed. So again, the idea that there were crystals came out of a certain scientist perspective who thought to write it down. It was observed before, but Louis Pasteur was the first to say, what's going on here that we can't describe? I think I've found something. So in 1848, he presented his findings to the Royal Society in Paris. And what's really fun, and as a historian, you're going to love this, 2 critical notebooks were lost.
Oh.
The notebooks with the observations and the notebooks with the first draft of his speech to the society. And so there was recently an article in Chemical and Engineering News, which is the organ of the American Chemical Society, talking about where these notebooks have come in and out of existence over the last 170 years. There's no intrigue. I don't think there's no salaciousness. I don't think the royal family was involved.
No, probably had a messy office.
Right. But, literally, people who had been contacted by interested scientists and historians of science, and people making requests to see the notebooks, and other people saying, oh, I'll get them to you right away, and they didn't get them. Or I'll take them to the Bibliothèque Nationale, and they didn't get there. And some person who actually admitted that he was too embarrassed to admit that he couldn't find them.
Right.
So he just didn't get back to them.
Yeah.
So actually, in the coming years, those documents will be viewed in their original form for the first time in 70 years.
Wow.
People have worked for microfilm and other
to reconstruct
objects.
them.
Yeah, but of course the microfilms have no pages for some reason.
Okay.
So now you're dealing with a sheaf of papers. It's like the Pentagon Papers all over again.
Just put the puzzle back together.
Yeah, so that's the wine piece.
Yeah. Well, speaking of puzzles, I don't know. These 2 molecules look just the same to me, right? We've got a white atom and a red atom and a blue atom and a green atom, right? Yours too?
Yeah, mine too. So it's all the same pieces. So these are called isomers, which is your basic Greek for same unit. Okay, we got your same carbon and your same 4 colored balls.
Yeah.
This is a model of how carbon bonds. It forms this beautiful tetrahedron, one of the Platonic solids. Okay, so we're going way back there. And what had been noted, Pasteur did not know this, by the way. So Pasteur made his observations in the absence of these models.
Right.
But basically, if you put the 4 parts together, hold yours up so that the blues are pointing towards each other. So what we see here, if we look carefully, is a mirror image, right? Right in between.
Exactly. The blue
There's a mirror
reflected
plane.
in blue, white and white, green. Yep.
Exactly.
It's a mirror.
So, when you look in the mirror each day, you're doing this little experiment. Now, what I'm going to do is, because there is no mirror, I can pick this up and try and put it on top of your model.
Oh, well, no. You've got the red and the green to... Oh, no, that's not right.
No, the blue and the white are right. Well, just switch them. Just flip them over.
Yeah, let's see.
Yeah, there we go.
The blue... Oh, no.
No.
Oh, here.
Here we go. The green and the white. No.
Oh.
The blue and the red. Try the red and the white on each other. It's all bright.
Yeah, there we go.
There
the
we
red
go.
and white.
Oh, you can't. Okay, so here it is.
They're not the same.
So the idea is the one in your left hand is left-handed and the one in your right hand is right-handed. And of course there's a more formal definition of that, but we don't really need that to understand the idea that not every mirror image is superimposable. And the word for this comes right from the Greek, handed.
Yeah.
Should I do the shoe demonstration?
You can tell us about the shoes.
Okay, so the shoe demonstration. So if you want to try this at home, Take off your shoes and put them on the wrong feet as if you're dressing early in the morning. Okay, we've all been there.
That's happened.
Yeah, so the idea is your feet are handed. You have a left foot and a right foot. Your shoes are handed. You have a left shoe and a right shoe. And so your left foot goes in your left shoe differently than your left foot goes in your right shoe. And it turns out that after Louis Pasteur had established this concept, it's found all over nature. And in shorthand, your proteins are left-handed and your sugars are right-handed in the colloquial, and not the other way around. And also, proteins are left-handed. They're not left-handed and right-handed. So this is great science fiction. All my science fiction fans out there who love Star Trek will remember a novel called Spock Must Die, where a mirror image Spock is created by the transporter. And they find out he's the mirror image because he has to go down to the science labs and make his own proteins that are right-handed instead of left-handed.
Because they otherwise wouldn't occur in nature.
Otherwise, he would eat them in and let them out.
Wow.
Undigested. We see this in our medicines. There are medicines we take every day where you take the left-handed and the right-handed version. And the one hand is completely effective and works for you. The other one you just excrete. There are more tragic stories of drugs where the one-handed drug is curative and the other hand of the drug causes birth defects or is toxic. Yeah. Let's talk about more fun things. Your nose can tell these things apart. So let's look at the big model here. So if we stand this beast up, this is a molecule called carvone, and the little white balls are hydrogens, and we have some oxygen over here. It's mostly carbon in the black and gray region. And what I have here, right in the center, I'll hold it by that atom, is an atom just like this. It has 4 different groups on it.
Yeah.
Right? And because it has 4 different groups on it, because of this center, it's a chiral molecule. The right-handed version, which I built, this is actually the right-handed version, smells like mint. And I happen to have some mint right here. So take some mint.
There we go.
Right? You get a nice, refreshing, maybe a mint tea or kind of a sweet smell, right?
Toothpaste. Yep.
Toothpaste, right? Toothpaste. So that's your right-handed sample in the mint. The left-handed version of carvone smells like dill. Okay, a much more savory flavor. You know, it is Oktoberfest. So you might be having some sauerkraut, which might have some caraway, which is closely related to dill. More of a savory.
Very much so.
It's actually quite lovely. So we'll be doing some cooking tonight. So again, same molecule, same number of carbons, same number of hydrogens, same number of oxygens. All the bonds are exactly the same, single bonds, double bonds. None of that is different. What's different is the right-handed version your nose detects as mint, the left-handed version your nose detects as dill.
Wow.
So
these aren't then proteins.
No, this particular class of molecules are called terpenes, related to turpentine. And these are the natural oils that add flavor and fragrance to our lives.
Right.
So like lemon oil, sandalwood oil, patchouli oil, all these fragrances that we're really familiar with are terpenes. And terpenes in many, many, many cases are handed. Yeah. So it's really fun.
It is fun. It is fun. You're actually teaching this concept in your classes, right?
In fact, this morning, my students had to take off their shoes and put them on their opposite feet. Always a fun one. So it's chirality time of year, and it just happens, I think it was timed in Chemical Engineering News so that you would have an article about Louis Pasteur, who founded this. And of course, Louis Pasteur is a household, everyone, pasteurized milk and, these other concepts that he came up with. I still love the idea, though, that he didn't have these models. They didn't think about chemicals in this way. That came about 50-odd years later, 50-plus years later, when Van't Hoff put forth a theory of how carbon bonded to create these platonic solids like tetrahedra.
Right.
So, once they sorted that out, all of a sudden chirality made perfect sense because their geometry was solid.
So what Pasteur
No pun intended.
could observe were these larger phenomena like the crystals.
Exactly. And now in our department, almost every person who's teaching in the chemistry department is teaching this concept in one way or another. It's that foundational. And we also have an instrument that our recently retired colleague Frida Texter spearheaded and worked with our current chair, Pam Arts, to obtain. And that is an instrument that uses right and left-handed light. Right and left-handed light, because like your feet in the shoes, right? This right-handed molecule will interact differently with right-handed light than with left-handed light. And we use that to detect molecular structures, particularly important in protein and nucleic acid structures, so foundational in biochemistry and biology.
Right.
And so again, it's something we all do. My favorite story about that instrument, it cost more than my house.
I believe it.
Yeah. But anyway,
But now we have it.
now we have it and we use it.
And we've got students who are interested, and we've got a wonderful constellation of faculty colleagues in the department these days, don't we?
Yeah, it's a good time to be in the chemistry and biochemistry department at Albright College. We have
You mentioned Frida's retirement, and
Frida's
of course she was,
retirement, yeah.
sort of the guiding spirit of the department,
an
and
institution.
managed to produce so many wonderful students, including Dr. Fetro,
Including our current president, yes.
and then
yes.
also to hire you and so
you're too
many other
kind.
colleagues.
Yeah. So we have just a whole constellation, I like that word, a set of techniques and expertises among all of the faculty that really distinguish us as a department. So, every college has technique X, every college has technique Y. Well, we've got X, Y, Z, P, D, Q, A, B, C in a mixture we have all the instruments, we have access to all the instruments, and of course we put our students in authentic ways and developmentally appropriate ways onto these instruments. So nothing is reserved just for elite students or top like honor students. All instruments are available for all students, and that's part of our success story, because as the students will self-attest, sometimes you're better in the lab than you are in the lecture. Lab is your thing, maybe not exam taking. And we've had many students go on and do research projects with us and then move into distinguished careers, regionally and nationally. And it's because of the access that they get to this group of faculty.
Early on in their training.
Early on in their
formation
training.
as a scientist.
Yeah.
Yeah. No, it's really exciting. I mean, I keep track of these students after they've left us, and it's so clear that they've got the wheels that they need to really roll far.
Yeah.
So the number of students that we've sent to Penn and to Cornell and to UConn and Washington.
Yeah. And we have we could have an alumni association meeting at Temple University, which has always been a strong school and has recently made investments that Albright College students have been able to tap into. What's really fun, you're more into Facebook than I am, but we keep in touch with our alums in different ways, and seeing them move on, and not just in their science, where some of our students are collaborating with the big movers and shakers in the field currently, but they're sending us these wonderful vacation photos, literally from around the world, and taking their liberal arts education. So, having a student go to, Trevor and Mary Kate were just in Morocco. And in addition to saying, hi, we're in Morocco, they're saying, and I learned in Barbara Fahey's art history class that the following patterns are involved in tile work that is historically important in this region. And you say, well, what's going on with that? Well, it's my liberal arts education.
Exactly. No, it's really a gratifying thing to see the competencies and sensitivities that people develop here as students. Good. And now, chirality is part of your own research and publication.
It is. So what we're really interested in my laboratory, so we work a lot with terpenes. We work in a system that's slightly larger than this. And what happens is when these molecules fold up on themselves, they fold up in right-handed and left-handed ways, right? And some of that is random. So again, absent any guiding factor, you will get 50% right-handed and 50% left-handed because there's nothing guiding a preference. Enter biology. Biology always enters a preference. That's why, your proteins are left-handed because biology keeps making left-handed proteins from left-handed starting materials. So our question is, when we get right-handed and left-handed terpenes, is that spontaneous because nature has, for a short time, lost control of the reaction, or is it directed so that, let's say, one particular plant
we've
generates
got
a
two
left-hand-
green plants here, and the question is, why is one right-handed and why is the other left?
Exactly. Why is it selecting that out? As a matter of fact, this is the first time I've used this demonstration for 20 years, and I've never thought to look at what's going on in this particular system. Again, because I've been interested in other ones that are, the flavors and fragrances. There's nothing like fresh herbs.
Yeah.
I'm after other systems that are more directed towards making medicines and biofuels. So, I kind of missed the forest for the leaves.
But still, fascinating stuff, and it's energizing you, and it's energizing our students. And
Yeah, I think science education relies a lot on keeping that gee whiz moment alive.
I do.
There's a lot of numbers, there's significant digits, there's scientific notation, there's
a lot of crunching.
It's like walking through a hall of mirrors with a blindfold on some days. But other days you're just like, wow, this is really cool.
Yeah.
And keeping your students, I'm gonna eat more of this, keeping your students alive to what happens there is really important and really valuable, and something that we're able to do. Field trip days.
Exactly.
We don't get many of them in chemistry, but when we do, we try to have a lot of fun with it.
Yeah, and it's a source of inspiration for them, but it's in turn a source of inspiration for us.
I get to do this every day. I don't know how you people with books and stuff get on.
We have plenty of fun. We have plenty of fun over in Masters Hall as well.
Well, this history of science, the idea that Louis Pasteur's notebooks could go missing. It must. I used to joke with our former colleague Jerry Ronning. Oh, when you go into an archive, it's all in a file drawer, right? And it's in alphabetical date order, right?
Right.
Isn't that how it works?
No. Again, it looks like my office. Great.
Yeah.
Oh, this has been. I've learned a lot, and I hope our friends at home have discovered something as well. And
yeah, go put your shoes on backwards, and you can experience chirality.
Food for thought.
Yeah.
Food for thought. Well-seasoned food for thought. Chris, it's been a delight. Thank you so much for joining me here on
Always a pleasure,
on the
John.
Albright Scholar.
Yeah.
And thank you as well. We'll look forward to seeing you in another month's time in November on another edition of the Albright Scholar. Good night.